This assessment asks us to calculate the relative ratio of rates based on a difference in energy in the transition states of 15 kilocalories per mole. The equation that we're going to use, let me explain how we have it set up. It's going to be the activation energy to form compound B minus the activation energy to form compound D. That value we know is 15 kilocalories per mole. Is going to be equal to RT times the natural log of the ratio of rates of forming D relative to forming B. Since the process of C to D has the lower activation energy, we're going to expect this ratio to be a positive number. We'll use the standard values for R in this equation. And so we can move this out of the way and do the math. We're given 15 kilocalories per mole, or 15,000 calories per mole. If we wanted to solve the equation that way, we'll solve it with kilocalories. But 15 kilocalories per mole is going to be equal to 0.001987, our value of R, times our temperature, 298. We'll leave the units off to save space, times the natural log of our ratios. When we do this math, we end up with 25.32 is equal to the natural log of our ratios of rates. We can take E to both sides, and that's going to give us a relative ratio of 9.91 times 10 to the 10th. So that ratio is telling us that D forms that much faster than B, a positive number just like we expected, or a number that is greater than 1, just like we expected.